How's it going, guys? My name is Dom, and today I want to talk about classes in JavaScript. So basically, for those of you who haven't ever used classes before, a class is used to create one or more objects. So you can think of an object as being a creation from a class definition. So these classes aren't actually used directly by your program logic, but they're used to create objects. Now these objects are the ones that are actually used by your program to achieve different things. So with that being said, you can define two main areas with a class definition. You can define what an object will have, so this is called an instance property, and also what they do. This is called an instance method. So with instance properties, taking into basically example of a human being, a human might have a name, an age, and a height. So an instance property describes the current state of that object, what they have. It's basically just data about that that object. So these instance properties are unique to every object which is created from that class definition. So we now have the instance methods. This is what they do. So an instance method for a human being might be to talk, to run, and to jump. So this refers to what they actually do, what actions, and their behavior. So typically an instance method will use the instance properties to achieve their result. So you have those two main areas right there. So let's now create a class in JavaScript. So down here, we can create a class definition by using the class keyword. Let's type out class like that, followed by the name of your class. Let's create a class for a rectangle. Let's type out rectangle right there. Now typically by convention, you want to use a capital letter at the beginning of your class name. So it's going to be rectangle with a capital R, just like that. Followed by two curly braces. So now inside here, this is your class definition. So every class also has what's called a constructor. Now the constructor is basically just a method which is ran only once during the life of the objects. So this constructor is ran once, and it's ran when the object is being created. So let's define this constructor by typing a constructor like that, followed by two parentheses and your normal curly braces. So the constructor is used to set up your object. Okay, so this behaves like a normal method or normal function, which means if I type out console.log inside here and then just say the rectangle is being created. Okay, so now this method constructor is ran when the object is being created. So we have a class. Let's now create an object from that class. So down here, let's create a new variable, and we'll call this one something like my rectangle number 1, which is then equal to a new object based off this class. Let's type out new. That's the new keyword, and then say rectangle just like that, and then two parentheses to actually call that constructor method. So if I was to hover over this, we see we get constructor just like that. So this will call the constructor method. So now if I was to save this HTML file and then refresh the web browser, in the console window we get the rectangle is being created. If I was to make two of these rectangles, so my rectangle number 2 down here, save this and refresh the browser one more time, we get two messages of creation. Okay, so that is how the constructor method actually works. Okay, the constructor is used to actually, obviously, as I said, used to set up the actual object. So back to these instance properties, what you might commonly see is the instance properties being defined inside the constructor. So we have a rectangle. Now a rectangle might have a width, a height, and also a color. So let's define these three instance properties within the constructor. So below here, let's define a instance property. We can do this by typing out this dot and then the actual property name. For example, width is equal to and then the value. Let's just say it'll be 5 for now. And we can do the same thing for the other two properties. We'll say this and then dot height equal to, let's just say something like 3, and the color, let's make this a blue rectangle. So this keyword right there, that is a keyword which refers to the current object. So when I say this, I'm talking about the object which is being created by that class. Okay, so we now have our three instance properties defined inside the constructor. So now if I was to save this and refresh the browser, and in the console, if I just refer to the myRectangle object or the variable here, okay, and press enter, we can see we get three properties, those color, height, and width, which describe the current rectangle. Okay, so these properties are unique to this rectangle instance. Alright, so in most cases though, you actually define instance properties when you construct the object, but these are typically user defined. So usually you would type in myRectangle and then say something like 3 and then 5, and also maybe the color, so we'll say blue like that. Okay, pop this out, blue. So you want to make this 3, 5 and blue actually turn out to be the instance properties for this created object. Okay, this allows you to make custom rectangles with whatever values that you actually pass in. So to achieve this result, you actually want to make the constructor function accept parameters or arguments. So let's type out an underscore here and then say height. Actually, let's start with width. So say width and then height and then color. So these are now three parameters which are passed in through the constructor function, and then these will be assigned to the instance properties of this particular rectangle object. So let's swap out this width with these actual variables right here. So now we're assigning the width of this rectangle to be width, height, and color, and so on. Okay, let's just make this a 5 and a 3. So now running this line of code right here creates a rectangle with a width of 5, a height of 3, and a color of blue. So these are all passed in and inserted right there. So now if I was to save this one and refresh the browser, we get the same result. Let's just log out the actual rectangle object. We get this rectangle, width of 5, height of 3, and a color of blue. So with this scenario, we can actually create two objects here, two rectangles once again. But for the second time, let's give different data. Let's say 10, 5, and then red. So now using this class definition, we're defining the structure of this rectangle, but giving it custom values based on the individual needs of this, I guess, current state in the program. So if I was to save this and refresh the browser, this time, if I type out rectangle number 1, we get width 5, 3 in blue. Number 2, we get 10, 5, and red. So we can see how the instance properties are unique to the actual object being created. We have two squares here with different instance properties for their data. So that is the actual instance properties and the constructor function. Okay. Now, for the instance methods, we can define these under the constructor. So, to work out, I believe, the area of a rectangle, you multiply the width and the height. So, we can actually create a method which will give us the area of this rectangle, or the rectangle being created. So, let's define a new instance method. We can do this by typing out the name of the method. Let's say get area. So get area right there, that is the name of our instance method, followed by the two parentheses right there, and then the brackets. So inside here, let's actually just return the width and the height of this rectangle. So let's say return this dot width multiplied by this dot height. Okay, so now we should get different return values from this method based on the rectangle being used. So for an example, down here, let's say console.log, and then let's say rectangle1.getArea. Okay, so using .getArea, this will call the instance method. So for this rectangle right here, we should get 5 times 3. For the second one, rectangle number 2, getArea, will give us 10 times 5. Let's save this and refresh the browser. We get 15 and 50. Okay, so you can see how these methods are defined in the actual class definition, and they're generic to the actual class, and then they're using the instance properties that are defined by the constructor to give you different results based on the object being used. Okay, now one more example of the actual method. Let's make a method that will actually print out a description of the actual object. Let's say print description. Okay, inside here, let's just say console.log, and then just say something like I am a rectangle of, and then let's just put the width and height. So we'll say this dot width, and then this dot height. Then we'll say, and I am, and then the actual color. So this dot color. So now, by calling this print description method on a rectangle, we get I am a rectangle of width times height, and I am then the color. So now down here, let's call the print description method on the my rectangle number 2. Okay, dot print description. If I was to save and refresh this one, we get the expected result, rectangle of 10 times 5, and I am red. Okay, so just to recap, we have a class, which is a definition, basically a structure of the eventual object being created. We have an instance property, which refers to data that is relevant to each individual object being created, and we also have an instance method which uses the instance properties to achieve an action or some sort of result based on, once again, each individual object being created from that class. Right, and that is the basics of classes in JavaScript. I want to talk about getters and setters in JavaScript classes. So basically, getters and setters are used to define methods on a class, which are then used as if they're properties. So essentially they look like properties, but they're actually methods of that class. So let's see with an example. I'm just going to define a class here in JavaScript, and we'll call this one square. Okay. For the constructor, let's just take in a single argument here called width, and that'll be the width and the height of the actual square. So inside here, let's just say this dot width is equal to that width parameter, and the same thing for the height. Okay, so now the square has a equal width and height. Okay, now we have this basic square. So to work out the area of this square, it'll be the height multiplied by the width. Okay, so we can actually define a getter to achieve this. So down here, let's create a getter for the area. We can do this by typing out get, just like that, then a space, and then specify the name of your getter. And this will be the actual name that you type out as if it's a property. So let's just say get, and then put down area, followed by parentheses. Okay, then the normal brackets there for the actual method body. So now inside here, this is now basically a function. We can put any logic we want inside here. We can do anything. So let's just return this dot width multiplied by this dot height, and that'll give us the area of this square. So you can see how I put a return statement inside this block, because it literally behaves as if it's a method. Okay, so now we can test this getter. We can create an instance of this square. So let's just go down here and say we'll say let's make a new variable, and say we'll call this one square1 equal to a new square with a width and height of something like 25. Okay, so now down here, let's just console.log, and then we're going to call this area getter by typing out square1 and then dot area. So you can see how it essentially behaves like a property. Okay, alright, so there's no need to put any parentheses here, because yeah, it literally is a property, right? Now if I was to save this one and then refresh the browser, okay, we get 625 as a result. So 25 times 25 would be 625. Let's make that maybe 4, just so we can get a small number. So square of 4 width and height, save and refresh, and we get 16. So you can see how we're calling this area getter, running this function body, but it behaves like it's a property. Okay, so that's the actual getter right there. So now let's actually create a setter. So a setter behaves basically in the same way. You can assign new values to your instance properties with a property-like syntax. So you can actually do this. You can say square1 dot area equals, and then something like 25, for example. So let's create this setter. So this right here, this line right there, will actually convert this 25 into a width and height for these two properties. Okay, so back inside here, let's just create a setter for area. So we'll say set, and then put area like that. Now this one is going to take a single argument, and that'll be this value right there. So let's say set area, in parentheses, let's put down area. Okay, so now inside here, we can now simply just find the square root of this 25, and then we can assign that result to the width and height of the square, because obviously the square root of the area would be the width and height of the actual square. So let's say this dot width is equal to the square root. So we'll use the math.sqrt method and pass in here the area. Okay, so now if I was to pass in 25 inside here, we'd say the width is equal to the math.square root of 25, which is actually going to be 5. Okay, so the width is equal to the square root, we can do the same thing for the height. So this dot height is equal to, and we can just say this dot width for, I guess, consistency. Okay, so now we can run this code, and that line right there will change the value of the width and height for this square. So let's just see how this thing looks. So let's get rid of that right there, and console.log down here, square1.area. Okay, let's save this and refresh the browser. Oh, okay, 25, yeah, of course. Let's actually just console.log the width of this square and also the height. Okay, let's try again, save and refresh, and we get 5 right there. So we have converted the initial width and height of 4 into 5 using this setter, which modified the width and the height based on the area that you pass in. That is the basics right there. I just want to show another example of how you can basically treat these like a function. So with this getter, let's actually keep track of how many times we have requested this square to give us the area. So every time I call this getter, I want to actually increment a number which tells us how many times we've called this getter. So up inside here, let's create a new instance variable, and we'll call this one number of requests for area, okay, equal to 0. So when it's constructed, we have no requests for the area. Inside the getter, let's just say this.num of requests for area plus plus. So now every time we request for the area, this will be incremented. So down here, let's just get rid of this that right there, and then let's just say console.log square1.area, okay, and do it, let's just say 4 times. Okay, so now if I was to then console.log and say square1.number of requests for area, this should now equal 4 because I've requested it 4 times, and that has been incremented 4 times. Okay, so now if I was to save this and refresh the browser one last time, you can see we get the area and also number 4, and that is how many times I've actually requested for the area. Okay, so that is how you can use getters and setters on classes in JavaScript. I want to talk about static methods in JavaScript classes. So basically, a static method is a method which you define on a class, but it is not actually part of the instantiated object once it's been created. So basically, a static method does not require an instance of the class to be created in order to be used. So a lot of static methods are what's called helper methods. So they're like little utilities that are relevant to that class, but not really, that don't have an object bound to them. So let's just see with an example. I'm going to define a new class here, and we'll go with the standard square example. So a class of square, and for the constructor, let's just take in a width, and the width will be assigned as per usual to the sort of width and height instance properties. Let's just say constructor, and we'll say this.width is equal to that width parameter, and this.height is also equal to that width parameter. So now we have a square class with a constructor. So now let's just create an instance of this square. So down here, let's create a new variable here and call this one square1 equal to a new square, passing in a width of, let's just say, 8. Okay, so now we have this square. So if I was to just console.log this square in the console, save this and refresh the browser, in the console we get obviously a square, width of 8 and height of 8. So now let's create a static method on this square class that's basically going to compare 2 square instances, and then let us know if they're of equal width and height. So in here, let's define a static method. we can do this by first typing out the keyword static, followed by the name of the method. So let's just say maybe equals, okay? Something like that, right? Equals, and then this method here will take in two parameters, or two arguments. The first one being obviously a square, and the second one being another square. Let's just say A and B. So A and B are two different square instances, alright? And the equals static method is going to check the width and height of these two squares and then give us the result if they are equal or not equal. So let's just return, then use the ternary operator. Let's just say return if a.width times a.height is equal to b.width times b.height, then return true. Actually, let's just return that. So now we're going to return the result of this expression, or this comparison here, if the area of the first square is equal to the area of the second square. Obviously just return that comparison result. So now this method should work. Let's test this out. I'm going to create another square here, square 2, with a width and height of 9. So we have two different areas for these two squares. And then down here, I'm going to console.log the return value of this equals static method. And I actually call a static method, you call it directly on the actual square class itself, and not on a square instance. Let's just type out square here, and then dot equals, okay? And here we're going to pass in square number 1 and square number 2. Okay, so now, if I was to save this and refresh the browser window, in the console we get false, because here clearly the area of A is different to the area of B. If I was to make the area the same, make them both 8, okay, so 64 here and 64 here for the area, save and refresh this one, we get true. So we can see how we've used a static method here. Now this static method doesn't require an instance for it to work. It does in the regard of the actual parameters, but the actual method itself doesn't ever say this or this area. So there's never any I guess referrals to the actual this keyword. Okay, so there's no instance binded to this static method. Probably a better example of this would be maybe a static method that will test whether or not a width and height is a valid square. So for a square to be valid, it needs to have an equal width and an equal height. Okay, so let's just create a new static method down here and call this one something like is valid, maybe is valid dimensions. Okay, this takes in a width and a height. So now this static method is technically relevant to the square class, so we're checking if a square is valid or a dimensions is valid based on the width and height. So if the width and height are the same, then it can be a valid square. Let's just return here. Let's just return the result of a condition. If the width is equal to the height, then it is a valid square. So let's just return width equal to height, that comparison result right there. So now, down here again, if I was to just console.log here, console.log, and then say, once again, calling the square class directly, and saying is valid dimensions, and passing in something like 6 and 6 inside there. If I was to save this and refresh the browser, we actually get true, okay, because obviously 6 is equal to 6, so we get the return value of true here. If I was to make this 7 and 6, well, we should get false in the console. Refresh and we get false. Okay, so static methods are used for, I guess, helper functions. So they're still relevant to the actual class, but they don't actually require an instance of that class to work. In fact, if I was to just get rid of these two guys right here, Okay, save and refresh. We still get the same result. There's no error or anything. So you can see how it's sort of like a helper function. Alright, and that's how you can use static methods in classes in JavaScript. I want to talk about inheritance, or the extends keyword, in regards to JavaScript classes. So basically, the extends keyword allows you to achieve the concept of inheritance in JavaScript classes. So you're basically going to use this whenever you have a generic class, and then you want to actually create a new child class of that generic one, while still maintaining its features and behavior, but a little bit extra. So basically, it's when you have a parent class to create a child class. Okay, so let's see how to actually do this. So I'm going to create a new class here, and this will be a representation of a person. So let's type out the class keyword and then just say person, just like that. This person will have, let's just say, two properties. We'll have a name and an age. So in the constructor, let's take in a name and an age, just like that. And then assign two instance properties. We'll say this.name equal to the name, and this.age equal to the age passed in. Okay. This will be our parent class, the generic class. Now, let's just say inside our code we have a function. Okay. This function, we'll call this one something like develop software. This function requires a bunch of programmers to develop the software. So this will take in an array of programmers, just like that. Okay. Inside here, basically we'll just say develop software. So each one of these programmers are going to develop some sort of software. So as you can see, a normal person won't be able to actually be passed in to this array, because we expect programmers, not a generic person with no attribute on their skill or occupation. So we're actually going to create a child class which inherits from this person class, and this child class is going to be a programmer. So we can achieve this by creating a new class, okay, and call this one programmer. Okay, now if we type out extends here, so extends and then say person, we've just achieved inheritance. So now we have a programmer which extends a person, which means it takes in all the attributes and behavior of this person, so name and age, and it also will have its own custom behavior and properties itself. So I might just create a new method inside the person real quick and just say something like describe or something like that. So describe, this will just simply console.log a message saying I am and then their name. So I am, I don't know, Dom, and I am age years old. Okay. Say this.name. So now this programmer class is going to have access to not only these properties, but also access to the describe method. Okay, so down here, let's create the constructor for this programmer. We'll type out constructor here. This will take in a name and an age. Okay, the same thing as the actual parent class. And also, let's just say years of experience. We'll say years of experience. Alright, so now inside here we actually have to call the parent class. Oh, sorry, the parent constructor. So we still have to actually assign the name and age, but we can do this in a more generic way by typing out super and then passing in name and age. So here, this super is basically just going to call the constructor of the person. That way all this logic is still maintained in this class. Okay, so super name age basically just calls this in the parent class. Now down here is the custom behavior of, if I can spell this out, behavior of the programmer. Let's just say this dot years of experience is equal to that parameter right there. Okay, so now before we define a new method for this programmer, let's just create some instances of these people. So down here, let's just create a new person, so a new generic person. So we'll say person1 is equal to a new person, and we'll pass in a name of something like Jeff and an age of something like 45. Okay, let's also create a programmer. We'll say let and then programmer1 equal to a new programmer, passing in a name such as, I don't know, Dom, myself, age of 56, and years of experience I've had about 12. Okay, not really, but that's alright. So now we have these two people, a person, we have one person here, another person, we have two people, but the programmer is a special type of person. Okay, so we can now console.log person1 and do the same thing for the programmer number 1. If I was to save this and refresh the web browser in the console, okay, fair enough. Let's just see what's happening here. Yep, cool. Put that there, perfect. Okay, save and refresh this one. Alright, we get a person, name of Jeff, age 45. Programmer, name Dom, age 56, and years of experience 12. So we can see how we have obviously this the same behavior as the person with extra added functionality of 12 years of experience. The prototype for this programmer is person, and you can see how it all works with the prototype chain and the inheritance. So you can see how this programmer is a child of this person class. Okay, so let's add some extra functionality to this programmer. Alright, so down here, let's just say develop, actually, let's call this method code. Okay, so make a new method here called code, and it'll just say, okay, console.log, and we'll say this.name is programming, or is coding. Okay, there we are. So now, obviously here, only the programmers have access to this method. So if I was to say person1.code, it's not going to work. Let's save and refresh this. Refresh. Uncaught type error, not a function. So a regular person cannot code. If I change this to programmer1, this time we get the message. Refresh, we get that right there. So you can see how we've added extra functionality to this programmer class while still maintaining the functionality of the person. Let's just prove this right now by calling the describe method on the programmer and not the person. Let's save and refresh, and we still get I'm Dom and I'm 56 years old. So you can see how we're maintaining the same behavior. So back to this function, we might as well finish it off. So let's just create a new array here. Get rid of all this stuff. Let's make a new array. Call this one programmers, equal to an array of programmers. So we'll say new programmer. We'll say Dom with 5-6 years old and 12 years of experience. We'll create one more. Let's just say Jeff once again. Okay, age of, I think it was 24, something like that, and he's got 4 years of experience. Okay, we might as well stop there, that's fine. Okay, so now we can just obviously pass in into this function here, develop software, and pass in these programmers inside the function body. Let's just loop through all these programmers. So we'll say for let programmer in programmers, I believe it is, and we'll say programmer dot code. Okay, so we're looping through all the programmers and just calling their code method. If I was to save this and refresh, what do we get? Okay, cool, that's fine. Yeah. Oh, I think it's of, isn't it? Yeah, it's of. Okay, get rid of that. Refresh this, and we get Dom is coding and Jeff is coding. Alright. And that's how you can achieve inheritance using the extend keyword in JavaScript. I want to talk about the concept of polymorphism in JavaScript classes. So basically, polymorphism is the act of redefining a method inside a derived child class of a parent. So let's just see with an example. We'll go with the typical animal example. So let's just define a new class inside here, and we'll call this one animal, which obviously represents a generic type of animal. Okay, so for the actual constructor, we'll just take in a single argument. This will be just the name of that animal. Okay, and we can set that to an instance property. So we can say this.name is equal to the name that is passed in the constructor. Alright, so now we have an animal with a name. So let's just define a new method inside here, and let's call this method makeSound. Alright, this will take no arguments. Now this method right here is the one that we're going to eventually override to achieve polymorphism. So let's just say for a generic animal, we're going to console.log, and we're going to say generic animal sound. Okay, so this is the makeSound method that is present in the parent class of animal, and it just says generic animal sound. So if I was to make a new instance of this animal real quick down here, let's just define a new constant and call this one A1 equal to a new animal, and we'll call this animal Dom. Alright, and then if I say A1.makeSound, just like that, we should now see that in the console. Let's just save this and refresh the web browser, and we see that right there. Okay, so that's fine. Now let's actually just create a new child class of this animal class and then override the makeSound method. Okay, so let's go down here and declare a new class. Let's call this class dog. Okay, so a dog is an animal, so let's just say dog extends animal. Alright, cool. For the constructor, let's just take in once again the name and then call the super constructor passing in name. So that means just call this constructor for the parent. Alright, so we have this functionality right here. Now let's just redefine the makeSound method, and this is called polymorphism. Okay, makeSound. This time let's say console.log and say woof woof. Alright, okay, so we are now done. So now if I was to make a new animal down here, or a new dog down here, new constant, call this one A2 equal to a new dog. Let's call this dog Jeff. Now we're going to call the makeSound method on the constant, which is the type of dog. Let's say A2.makeSound. Alright, if I was to save this and refresh, this time we get woof woof in the console. Alright, so we can see how we're actually achieving polymorphism here by overriding the method inside the child class dog, of that in the parent class makeSound. So we're just basically overriding it. So if I was to comment that out in the child class and save and refresh, we get once again the generic sound. So what's happening here is it's actually checking on the dog class if it has that method. If it doesn't, then it checks the parent class and it uses that one right there. Alright, so that's polymorphism. I'll just show one more example, this time calling the super inside the actual overridden method. So I can actually call the parent method inside the derived method. So inside this makeSound method, I can say super.makeSound, and that right there is going to call the parent class animal.makeSound. So we'll actually see that message followed by that message. And this is common practice. You'll see how we're actually using the generic behavior and then adding on special functionality for the special derived child class. If I was to save this and refresh the browser, this time we see here generic and then woof woof. So these two right here are part of the dog.makeSound method call. Okay? And that's how you can achieve polymorphism inside your JavaScript classes. I want to show you an example of how you can use JavaScript classes to make a binding to a HTML element. So what I mean by this is we're actually going to be able to create a class which can then manipulate the DOM, or the document object model, directly. So for example, here I have an unordered list element on the HTML document with a few list items inside it. Okay. In the JavaScript, I can actually just type out list and then .add, and then add an item to that list directly. So for example, list.add bottle, press enter, and we see bottle appears right there. We can do the same thing for removing an item. Let's say list.remove and pass in an index, for example, index number 1. Press enter, and is removed. Okay, so we're going to make this right here. So inside the clean document here, we have a simple structure. So first, let's just create the actual unordered list item to use. So let's say UL with an ID of something like my list. Okay. So this list will be filled by JavaScript. So let's just say, we'll put a comment down. We'll say, to be filled by JavaScript. Okay, so now we need to actually reference this list element in JavaScript. So using the actual ID here, we're going to make a new constant which references this unordered list element. So down here, let's make a new constant and call this one something like my list equal to document.getElement by ID, passing in my list right there. So now my list means that element right there. Okay, so now let's start creating the actual class. So let's make a new external file here. Make a new file. Let's call this class listBinding.js. Okay. Let's now link this class in the actual HTML document. We'll say script with a source of listBinding.js. Okay. So in this class here, let's just actually firstly define this class. We'll say class and call this one listBinding. Okay. So in this class, we're actually going to be able to pass in the myList element to the class constructor. Okay, so this class will actually keep a reference to the physical tag or element. Okay, so in the constructor, let's just take in a single argument. We'll call this one element. Okay, now we can say this.list element is equal to element. Okay, so we have an instance property here called list element, referring to the physical list HTML element. Okay, so now we can make a underlying simple array that will be filled with all that text. So we can say this.textList is equal to an empty array. So this text list here might contain some strings. For example, decode is not bad. Okay, so back in the actual demo, we have that right here. So we can see how this array structure will eventually actually contain all these text items right here. That's what the actual text list property is used for. Okay, so now let's just make an instance method for this class, and let's call this method update. Say update. This will take no arguments. The update method is actually just going to update the physical DOM, so the physical list element, with the items contained in text list. So we maintain an array of strings, and then the update method is actually going to insert all these strings into the physical list element property or list element. So down here we can start by first clearing the list element of list items. So let's just say remove all existing li elements or /tags. Okay, we can say while this.listElement.firstChild, so while there is a first child, then we can say this.listElement.removeChild and pass in the first child. Okay, so this right here is going to remove all the existing li tags from the list element. So let's just see an example of this in use. So back inside the HTML, let's just put some sample li tags inside here. We'll say item number 1 and item number 2. Okay. Inside here, let's make a new constant, okay, called list binding. This is equal to a new instance of that list binding class. We'll say new list binding, taking in my list. Okay, so this is like registering this list element with this list binding class. Okay, let's save this and refresh the browser. We get that right there. So now let's call the update method on that list binding and see what happens. We'll say list binding.update, and they go away. So you can see how that code right here removes all the existing list item tags. So now we have to add let's just say fill. So fill ul/ol tag with li. Okay, let's just fill up this list element with all these strings inside this text list array property. So let's just say for each of the text list items, so for each const text of this.textList, okay, we're going to say this.listElement.append child, and we're going to append obviously a li tag. So how do we actually convert a string to an li tag? Let's just say this. Let's just say list binding dot create list item and pass in text. So we're going to make a static method called create list item, which will generate an HTML element for the text that is passed in. Alright, so let's just make this static class or this static method right now. Up here, let's say static, call this one create list item, which takes in a single argument being text. Okay, for the body, let's just make a new constant here, call this one li, equal to document.createElement of an li tag. Okay, then say li.textContent. Let's put the actual text inside the actual tag, and then return ally. So now this method actually makes an ally tag, okay, or element slash tag with text inside. They actually pass in right there. All right. So now, if we actually put some sample data inside this array, for example, decode and then I don't know, bottle. Okay. If I save this and refresh the browser, we still get these two existing elements, right? If we say list binding dot update now, press enter, they get replaced. So here we are first clearing the existing elements, so we clear them with that right there, and then add ally tags for each text or each string inside this text list underlying array right there. Okay, let's make this back to no elements. Okay, so now let's actually create the add and remove methods. We can first just get rid of those sample tags. Okay, save this. Alright, so let's make the add and remove methods. So basically, these two methods right here are simply just going to update the underlying array, that guy right there, and then call the update method. So it's going to be quite lean and loose coupling. Alright, so down here, let's make a new add method. Alright, this will take in some text. We'll say text just like that. Inside here, let's just say this.textList and call the push method. We're going to push text to the array. So this will add this text to this underlying array. Quite simple. And then we're going to say this.update. Alright, so basically the add method does its simple job of adding the actual text to the array. Then the update method does its job of updating the actual physical document object model, the actual HTML page. Alright, let's just save this and test it out. Save and refresh the browser. Alright, let's say list binding dot add. Alright, let's add decode to the list. Boom, there we are. Let's add some more, for example, add dog. So it works completely fine. Alright, good. For the actual remove method, for remove, let's add this method right here. This will take in an index. So remove an item at a particular index. Index right there, okay. Then, once again, it'll follow a similar sort of structure. It's going to say this.textList.splice. Alright, that's an array method. Splice at the index, okay, and then 1. So this means remove an item starting at, or multiple items, maybe, starting at this index, and then how many. So remove an item at this index, but only one of them. Okay, so that actually removes one item. This.update. Okay, so similar thing, modify the existing underlying array, and then update the DOM right there. Let's save this and refresh the browser and test it out. Let's add dog, decode, and let's just say bottle. Okay, and then we'll say list binding dot remove at index 1. Press enter, boom, there we are. Alright, so that's the whole thing done, but I'll just recap what's actually happening. Alright, so what's happening? Well, in this class here, actually let's start with the actual HTML. So in the HTML, we are making an unordered list element right there, which is then passed into the JavaScript through that method right there. And then we're making a new instance of the list binding class, passing in the actual physical unordered list element. From there, in the class, in the constructor, we are maintaining a reference to the actual list element property, and then making an underlying array to store all these strings of text to be displayed. Inside the update method, we are removing all the existing list item elements and then filling up the actual UL or the OL tag, so this guy right here, with the actual text inside the underlying text list array. This is done by calling the static method createListItem, which simply just makes a list item element, putting the actual text inside that. For the add method, we are simply just adding an item to the actual array, and then using the update method to actually update the DOM once that has been added. So we're keeping things lean. We're only actually updating what we need inside the add method. Same goes for the remove method. We're just removing an item at that index, and then once again passing it over to the actual update method to do the actual DOM visual work. Alright, and that's how you can make a binding from a JavaScript class to an HTML element inside your JavaScript classes. Thank you for watching, and I'll see you later.